Okay, doing the problem statement for the Coney Island hot dog. And you can see that we have hot dog contests. They're $10 a piece. But to motivate people to eat more hot dogs, we discount each hot dog whenever they go past a certain milestone. So you can see here um, where is that? So you get 60% off if they do 30, and they get 40% off if they do 20, and they do if they do 10, they get 20% off them. We don't want to soak them for the hot dogs that they make, but we don't want everyone coming up and eating free hot dogs because that would ruin the money that we're trying to raise. So everybody doesn't eat free; they eat hot dogs, and they're pretty expensive unless they eat a lot of them. All right, so when we take a look at it, we open up Notepad++, and you can whoa, 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 and you can see that I've already done this once before. So I've copy and pasted the problem here so that I can go ahead and put it together. But I've done a lot ahead of time because this is going to take a long time if I do things that I've already done before. So what did I do? It showed the receipt that they want this right here. So I copied that and I pasted it down here. And they say they want to see how many dogs, how much per dog that they were charging, and then how much did the person owe for the hot dogs that they ate. And then I went up here and I did our constants, and I seen that the hot dog rate is usually $10. It's 20% off for 10, and it's 40% off for 20. You can see I put the cutoffs there, and 60% off for 30. So all the constant number. Oh, forget this right here. I had made this a more difficult problem, adding gender in, but we're not doing that, so don't worry about it. And hopefully nothing's up there about gender. I'm pretty sure I'll take that out. So I didn't want. I start out making these a certain way, and then when I find out that they end up being too complicated, then I go ahead and all right, let's just back it off a little bit. All right, and then I had to figure out where am I going to get these from, and which ones are going to be input and which ones are going to be calculation/logic. And the rate per hot dog is going to be math and logic, and the amount owed is just going to be math. But number of hot dogs, someone has to tell me that. So you can see I placed that into here. And then I just copied these two because that's going to be math and all right. So the amount owed is going to be pretty easy. So, and we always start with the bottom one because it's the easiest math. And if I know how much they're going to charge for each hot dog, and I know how much hot dogs they ate, then very easy. All right, so that's just going to be num hot dogs times the rate per dog. Very good. All right, and then rate per dog all depends upon the discount. So the discount is off the $10. So each one of these is going to have to be multiplied by that. So it's going to be the rate per dog is going to be the hot dog rate. Whoops. Hot dog rate times the discount. But I don't know what the discount is, and there's three of them. So I'm just going to say the discount or disc rate. I don't know what the disc rate is. And it all depends on how many hot dogs they eat. So that means that's going to be placed in there by logic. But I don't want to put this entire math inside the decision. All I want to do is figure out one thing. And that's an important thing to remember. One of the inefficiencies that students usually put into their solutions is that they do too much math inside their decisions. If you're doing math, the same math, through each of the decisions, then you should remove that math and just use the number that you're multiplying out. So all we need to do now is find out what the disk rate is, and we're done. So let's go ahead and take a look at it. The disk rate is going to be either 20, 40, or 60. So I have to determine which I should do first. So if I say if num hot dogs is greater than the low cutoff, then the discount rate is going to be equal to the low consume rate. So if it's greater than 10, right? Because 10 is the first cutoff. So if it's greater than 10, they get charged 20%. They get 20% off. So if we take a look at this math, it's going to work if hot dogs are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and if it is 11 through, what's the next cutoff? 20. So 11 through 20, this is going to work fine. But what if it was 21 hot dogs? You can see that 21 hot dogs is greater than 10. So you can see that it's not going to give me the correct answer unless the number is between those two. So this is not the way to go. I shouldn't go with this first one. So how do I know which decision has to be first? Well, what you want to do is we want to remove populations, if that makes any sense. So as I mentioned, this right here is 11 hot dogs through 20 hot dogs, those 10. Well, what happens if I instead used high cutoff? Whoops. If I used high cutoff, that is 31 hot dogs, 32, 33, 34 through infinity, which is a lot of hot dogs. So you always try to get rid of your biggest population, and certainly infinity is large. So we're going to start first by trying to start with the high one and work down, and then we won't have that problem with starting with the low one and then realizing that it's going to give me the wrong rate. Now I can fix that by saying number of hot dogs through low and less than the medium, but that's a complex decision and it's a waste of time and a waste of energy. This is the way to go. So this is not going to be the high consume rate, low consume rate. This is going to be the high consume rate. Make sure that we got everything right. And let's get rid of this. And then we just work our way down now that we know that we started with the highest one. So the next one down, of course, is going to be the 20 hot dogs. So I'm not going to say if num hot dogs. I'm going to say if it's not true that it's greater than the high cutoff. So I'm going to start this with else. That means the first decision was not true. And then ask another decision. So we're going to use that else if again. And that is number of hot dogs greater than, and this is going to be the mid one now, and we'll just work our way down. The mid cutoff, if that's true, then the disk rate is going to be equal to the mid consume rate. I don't know what these names. All right, and then the next one is again, if it didn't meet the mid criteria, else. Let's see if it met the next criteria, which is num hot dogs is greater than the low cutoff. And if that's true, then the disk rate is going to be the low rate. So now we have those three rates, and the question is, what happens if they don't meet any of those? Well, since we're doing the math with the disk rate, we're going to have to do an else, and that is that the disk rate is going to be equal to 0. There's going to be no disk rate, and we're going to fix this when we code it so that we can eliminate this one. But now when we talk to our user, they see, oh, they don't get a disk rate here, they get a disk rate here, here, here. It's very easy for a person, even though they don't know anything about computers, to be able to understand this type of logic. And then we'll take that disk rate, multiply it by the hot dog. Hot dog rate. That's not right. This is, yeah. Okay. A hot dog rate, and that's going to give us our rate per dog and amount owed. So everything here looks like it's working perfectly. We have scope, we have constants. So I'll put the scope in here because we're running at 10 minutes now just explaining this logic right here. But it's important for you to remember, you always get rid of the highest population first. Now, if everybody got a discount, including the zero down to zero, which wouldn't make any sense, but suppose it was, then I could either do the low one first and say less than the low, or the highest of the high. And you'll see that this type of organization is the most efficient, usually starting with the high, because we want them to get the highest discount possible, not rip them off. So we're going to start with the high one first. All right, now we're on to flowchart. And when we flowchart, we're going to find out that our math is not going to work. You might have noticed it already, but we will see that. And that's one of the reasons why we do the flowchart, is to find out when we have errors in our problem statement. All right, on to the flowchart.